At the end of this video, you should be able to describe the purpose of the scientific method, distinguish between qualitative and quantitative observations, and describe the differences between hypotheses, theories, and models. Chapter 2, Section 1, Scientific Method. Sometimes progress in science comes about through accidental discoveries. However, most scientific advances result from carefully planned investigations. The process researchers use to carry out their investigations is often called the scientific method. The scientific method is a logical approach to solving problems by observing and collecting data, formulating hypotheses, testing hypotheses, and formulating theories that are supported by data.
Most scientists follow these 7 basic steps of the scientific method. First, scientists make observations. For example, paleontologists observe fossilized dinosaur remains in order to learn about dinosaurs that once roamed the earth. A scientist's observations often lead to questions. Upon discovering a set of fossilized dinosaur bones, a paleontologist would likely ask, what kind of dinosaur do these bones come from? A scientist often investigates a question by forming a hypothesis. The paleontologist in this example hypothesized that the bones he observed come from a type of dinosaur that had not yet been discovered. Scientists test hypotheses by gathering data that can help determine whether the hypotheses are valid or not. A test to support the hypothesis that a new dinosaur has been discovered might involve measuring many different parts of the newly discovered bones. Then these measurements can be compared with those of bones from known dinosaurs. Once scientists finish their tests, they must analyze the results. An analysis of the dinosaur bone measurements and the comparisons might show that the new dinosaur bones are either too large or shaped too differently to have belonged to any of the comparison dinosaurs that have already been discovered. Or, the test might show that a dinosaur matching the new bones had already been discovered. Finally, scientists must conclude whether the results of their tests supported the hypothesis. Let's suppose that the dinosaur bone measurement tests led to the conclusion that a new dinosaur species has been discovered. Upon completing an investigation, scientists communicate their results. Scientists often present their findings in speeches, journal articles, and books.
Observing and collecting data. Observing is the use of the senses to obtain information. Observation often involves making measurements and collecting data. The data may be descriptive or qualitative or numerical, quantitative in nature. Numerical information, such as the fact that a sample of copper ore has a mass of 25.7 grams, is quantitative. Non-numerical information, such as the fact that the sky is blue, is qualitative. Experimenting involves carrying out a procedure under controlled conditions to make observations and collect data. To learn more about matter, chemists study systems. A system is a specific portion of matter in a given region of space that has been selected for study during an experiment or observation. When you observe a reaction in a test tube, the test tube and its contents form a system.
Qualitative data describes the qualities of an object. For example, these bananas are yellow and have a smooth skin. They are firm to the touch but bruise if much pressure is applied. Qualitative data may be subjective. In describing the taste of the bananas, one person may categorize them as strongly marked by isoamyl acetate, another as having a mild flavor reminiscent of apples or peaches, while yet a third might find them sweet and creamy with a very bland flavor. Quantitative data measures properties. For example, this banana is 16 centimeters long and has a mass of 112 grams. Both of these pieces of data are objective. If another person repeated the measurement with the same banana, the results should be the same.
Formulating hypotheses. As scientists examine and compare the data from their own experiments, they attempt to find relationships and patterns. In other words, they make generalizations based on the data. Generalizations are statements that apply to a range of information. To make generalizations, data are sometimes organized in tables and analyzed using statistics or other mathematical techniques, often with the aid of graphs and a computer. Scientists use generalizations about the data to formulate a hypothesis or testable statement. The hypothesis serves as a basis for making predictions and for carrying out further experiments. Hypotheses are often drafted as if-then statements. The then part of the hypothesis is a prediction that is the basis for testing by experiment. In Figure 2-2 on page 30 of your text, or on the screen now, we're showing data collected to test a hypothesis. A graph of data can show relationships between two variables. In this case, the graph shows data collected during an experiment to determine the effect of phosphorus fertilizer compounds on plant growth. The following is one possible hypothesis. If phosphorus stimulates corn plant growth, then corn plants treated with the soluble phosphorus compound should grow faster, under the same conditions, than corn plants that are not treated.
A hypothesis is a theory or explanation that is based on observations and that can be tested. Two engineers named James Sarnowski and Michael Triantafilou had a question. How could they build a better boat propulsion system? A propulsion system is what makes a boat move. Most boats are driven by propellers. Sarnowski observed penguins swimming at the New England Aquarium. His observations led to the hypothesis that a boat propulsion system that mimics the way a penguin swims will be more efficient than propulsion systems that use propellers. The engineers built a boat called Proteus with flipper-like paddles that moved out and then in, much as a penguin uses its flippers underwater. Their tests proved that their hypothesis was correct. Proteus is 17% more efficient than a propeller-driven boat.
Testing hypotheses. Testing a hypothesis requires experimentation that provides data to support or refute a hypothesis or theory. Do the data in Figure 2-2 on page 30 of your text, or 2 slides previous, support the hypothesis? If testing reveals that the predictions were not correct, the generalizations on which the predictions were based must be discarded or modified. One of the most difficult, yet most important aspects of science is rejecting a hypothesis that is not supported by data. Theorizing. When the data from experiments show that the predictions of the hypothesis are successful, scientists typically try to explain the phenomenon that they are studying by constructing a model. A model in science is more than a physical object. It is often an explanation of how the phenomenon occurs and how data or events are related. Models may be visual, verbal, or mathematical. One of the most important models in chemistry is the atomic model of matter, which states that matter is composed of tiny particles called atoms.
Models are used to represent things that are too small to see, such as atoms. Models can also represent objects in the solar system that are too large or far away to observe in certain ways. For example, this model can be used to show how the movements of the Earth, the Moon, and the Sun result in the different phases of the Moon. Scientists and engineers use computers to model systems and processes that are too expensive, complex, or dangerous to test in real life. For example, computer simulations use data related to ocean temperature and weather patterns to predict El Niño events, and decide when to evacuate citizens prior to a hurricane making landfall. Models can also be used to represent ideas, concepts, or theories. For example, scientists noted that a rolling object, such as a push lawnmower, veers when it encounters at an angle a surface that slows it down. Light similarly veers when it passes from an easy-to-go-through medium, such as air, into a thicker medium, such as water. Scientists use the lawnmower model to help explain why light might exhibit such a behavior.
If a model successfully explains many phenomena, it may become part of a theory. The atomic model is part of the atomic theory, which you will study in Chapter 3. A theory is a broad generalization that explains a body of facts or phenomena. Theories are considered successful if they can predict the results of many new experiments. Examples of the most important theories you will study in chemistry are kinetic molecular theory and collision theory.
A scientific theory is an explanation that has been tested by repeated observations. Theories can be changed or replaced as new observations are made or as new hypotheses are tested. For example, the Big Bang theory is an explanation for the origin of the universe. The Big Bang theory states that the universe was once compressed into a small, hot, and dense volume that exploded and expanded in all directions. A theory tells you why something happens. The law of universal gravitation says that if you drop a book, it will fall and hit the ground. Laws only tell you what happens, not why it happens.
Figure 2-3 on page 31 of your text, or on the screen now, shows where theory fits into the scheme of the scientific method. The scientific method is not a stepwise process, however. Scientists may repeat steps many times before there is sufficient evidence to formulate a theory. You can see that each stage represents a number of different activities. At this point, you should be able to describe the purpose of the scientific method, distinguish between qualitative and quantitative observations, and describe the differences between hypotheses, theories, and models.